Okay, we're going to continue in Appendix C, and now we're moving on to section C.2, which is the Cartesian plane and the distance formula. The Cartesian plane, it's a two-dimensional plane, and it was established by René Descartes, who was a French mathematician and philosopher. For one dimension, the variable x, that's really one dimension, one variable, the number line was perfect for that. And we were able to establish locations on the number line, determine which numbers were larger or smaller. But when you have an ordered pair, and you have both an x and a y, two different unknowns, Descartes decided to have a horizontal number line to represent your x and a vertical number line to represent your y, thus forming a plane. So the Cartesian plane is also referred to as the rectangular coordinate system because it looks rectangular. So I'm going to go ahead and get started here, and I'm going to draw our Cartesian plane, and we're going to talk about the four quadrants of the Cartesian plane. So let's get started here. I'm going to use a straight edge, my x-axis, and my y-axis. This being the x-axis, the horizontal, and y being your vertical axis. Now, immediately what happens is it actually breaks the Cartesian plane up into four very distinct quadrants. So I'm going to go ahead and mark this off just like any number line with positive and negative quantities. So we'll put a 1, 2, 3, 4, 5. And naturally, it's a number line. It does go on forever. This is a -1, -2, -3, -4, -5. Arrow indicates it goes on forever. And now let's mark off the y values. Positive y values are up above. Negative y values are down below. So -1, -2, -3, 4, and -5. So we can certainly mark these off as well. -1, -2, -3, -4 and 5, and this is 1, 2, 3, 4, 5. It continues on in both directions, top and bottom. So you see very clearly the four quadrants. This is labeled as quadrant number 1 because in here you have positive x values, and you also have positive y values. Just like angles, we rotate in a counterclockwise direction, so this becomes quadrant 2. This becomes quadrant 3, and this becomes quadrant 4. So there are your four quadrants on your rectangular coordinate system or Cartesian plane. Now, if I want to determine the location of an ordered pair, like 2, 5, for example, your ordered pair is in order. It's a pair of numbers, the first being your x, the second always being your y. So we would establish x being 2. So you can actually, if you want, you could draw a vertical line here at 2 because basically this is all of the coordinates that have an x value of 2. And a y value of 5, you can actually draw a horizontal line here at y equals 5, thus locating the point of interest, 2, 5. Now, if I were to draw a point here in space on the Cartesian plane and say, can you please label that? The process is quite similar. What you want to do is look up or down to the x-axis, and that will certainly tell you your x value. So this x value here will be -3. And you want to look left or right, whichever one will get you to your axis. And there's my y value, -2. So whether you're given a point or you're given a location on the Cartesian plane, you should be able to translate it one way or the other. You notice that all x values are positive in here and all y values are positive? Do you notice that all x values are negative in this quadrant, but all y values are positive? And I can even use this point right here to clearly point out that my x values are negative and my y values are negative. And finally, in this quadrant, all my x's are positive and all my x's are negative. So there's definitely a difference between these four quadrants. Okay, that's the Cartesian plane, and we're going to locate coordinates on the Cartesian plane And we're also going to identify coordinates by their x, y locations. The next thing I want to discuss is the distance formula. Remember, we like distances to be positive. There is such a thing as a directed distance, and a directed distance can be positive or negative, and it tells me which direction. But for the most part, when we talk about distance, I really just need a measurement, which is a positive number. What I want to be able to do is I want to measure the distance between 2 points. The distance between 2 points on the Cartesian plane. So before we develop the distance formula, first, let's just establish the distance between 2 points that happen to be just separated in the horizontal dimension. So I'm going to go here to 1, 2 in my y. I'm going to go to here to maybe 3 in my x and place a point. We'll call this point x1. Let's march over here to 4, 5, 6, all the way out here to 7. Let's call that x2. And then let's place a point here. So let me call out the coordinates of these points. This is 3, 2, and this is 7, 2. So the real question is, what's the distance between these 2 points? Now I'll tell you it's pretty straightforward to do the distance when they're horizontally aligned like that, because the distance is nothing more than the difference of the 2 x values. So in this situation, distance will be nothing more than the difference of the 2 x values. But what if we get those in the wrong order? That's possible. Maybe x2 is here labeled, and this is x1. So to ensure that you get a nice positive measurement, we make sure that we protect that with an absolute value symbol, and now we know we're going to get a positive answer no matter which order we do this in. So the distance between these 2 points is the absolute value of 4, which is simply 4. And it wouldn't really matter what order you did that in. You'll get 4 both ways. The next scenario would be 2 points that are aligned with each other vertically. So let's go here to 1, 2 in the x direction. And let's go here to the y direction. And maybe let's place a point down here at -1, 0, 1, 2, and let's go up to 3. So I'm going to place a coordinate here, and we certainly know how to label our coordinates. That would be a 1, -1, x first and then y. And then we'll put a point up here, and we'll label that one as 1, +3. Let's label this one y2 and label this one y1. And we don't really need to label the x. It's the same x value. So in this scenario, the distance would be just the difference between the 2 y values. But once again, let's protect that value so it's positive. So it's going to be y2, which is right here, 3, minus y1, which is -1, but double negative in there is going to cancel. So I get the absolute value of 3 plus 1. I get the absolute value of 4, which again is 4. So the distance between those 2 points is 4. Now, those are pretty straightforward. Those are pretty easy, really. Difference of the x's, difference of the y's. No real sophisticated formula there other than the absolute value just to assist us in getting a positive reading. What about when the 2 points are not aligned vertically or horizontally? And that's really where the distance formula comes into play. So let's take 2 points on our Cartesian plane, x and y. Let's put one here. And let's put one over here, diagonally oriented away from the original. And let's connect the dots and make ourselves a nice line. And what I really want is the distance d. Now, there are 2 measurements we could make, but before I do that, let's label this as x1 and y1, and we'll label this as x2 and y2. So naturally, if we look down to the x-axis, we should be looking down here at x1, and if we look down here, we should be looking at x2, and in fact, I'm beginning to see a triangle right now that's resolving itself with this vertical and horizontal line. In fact, I can even label this point because I see my x2 value there. And if we look across, this must be y1. And if we look across up here, this must be y2. So this coordinate here must be x2, comma, y1. And so if we could get the distance of this line segment and the distance of this line segment or measurement, I bet you we could get the measurement of our distance between our 2 points. So let's start with A. A is just like the previous problem, 2 points that are aligned horizontally. So that means you simply need the difference of your x values. Protect that so that it's positive. B is this distance, which is 2 points that are aligned vertically, and that's simply the difference of my y values. But same thing, let's protect that so that we get a nice positive measurement. And if I simply come in here and make D equal to C, I think you know the formula we can use on a right triangle like this. It's the Pythagorean theorem. So if we break out the Pythagorean theorem, it looks like this. A squared plus B squared is equal to C squared. Let's try that. My definition for A is right there. x2 minus x1 squared, absolute value. Definition for B is right there. The difference of the 2 y values squared. And you know C and D are the same thing. Do we really need the absolute value symbols anymore? Because look at what we've got in our formula. We've got squared. And when you square anything, it comes out positive anyway. It's like got a built-in absolute value symbol. So you don't really need them now. So we can get rid of those superfluous absolute value symbols. They're not needed. Squaring will make it positive anyway. And there's one last step, and that's to get rid of the square. We want D. So take the square root of both sides. Square root of that side is D. Square root of this side is the square root of that side, which is the square root of the difference of the x's squared and the difference of the y squared. So now you know where where the distance formula came from. It came from the Pythagorean theorem. So pretty straightforward that is the origin of the distance formula. So let's use the distance formula. Let's use it. Let's apply it. I'm going to give you really maybe 3 points. And, well, actually, I'll give you 2 points. Let's find the midpoint. And then let's measure the distance of the 2 segments and see if they're really equal, if we really got the correct midpoint. So I'm going to give you a coordinate here. Let's call it 1, -2. Let's put one up over here. Let's make that, how about 7, well, we got to make it positive here. Let's make that positive 8 up here. And the first thing is, let's get the midpoint. Now, the midpoint is simply the average of the x's and the average of the y's. So if I want the average of the x's, let's label these. x1, y1, x2, y2. The average is just like averaging 2 test scores together. You add the 2 x values together and chop it in half. For the y's, you add the 2 y values and chop it in half. So what's our midpoint going to be? So x1 plus x2, that's 7 plus 1 is 8. y1 plus y2 is 8 plus minus 2, which is 6. And so the coordinate of that midpoint is 4, 3. So now I can label that. Now, if it's truly the midpoint, would you not agree that distance 1 and distance 2 should be identical right here at the midpoint? So let's try that. So I'm going to measure the distance between the first point and the midpoint. I'll measure the distance between the midpoint and the last point. And let's just see if they're equal. So what's distance 1 going to be? Square root of the difference of the x values between those 2 squared, and the difference of the y values. Now be careful, minus a minus 2. So what is distance 1 going to be? So square root of 3 squared plus 5 squared, which is the square root of 9 plus 25, which is the square root of 34. That's in simplest radical form. There's no perfect square hiding out in that number. What's D2? D2 is another square root. It's the distance formula. Let's do the difference of the x's. That's 7 minus 4. Let's do the difference of the y values. That would be 8 minus 3. Let's see what we got. 3 squared, 5 squared. Looks familiar to me. Square root of 34. We really did get the correct midpoint. And so the distance of the entire line segment from start to finish must be 2 times the square root of 34, because we have 2 of those segments. So that's it for Cartesian plane and the distance formula. Please practice some of the homework problems. There are problems in there that tell you to verify that you have a right triangle. And the way I would do that is, because the right triangle is going to be maybe rotated one way or the other, it's not going to be easily detected, I would measure all 3 sides using the distance formula. And then to verify it's the right triangle, a squared plus b squared must be equal to c squared. You'll have the length of all 3 sides because you'll have used the distance formula. So we'll see you in the next video. And in the next video, we're going to be covering completing the square. Thank you.